Okay, so in this first identity, we have the left side is power 2. Sorry, I'm just moving my desk so I don't. Okay, so I'm going to put this on another page just so we have room. Okay, so remember our strategy is that we would like to put everything in sine and cosine if it is not already, and then simplify from there. Okay, so on the left side, we have cos x minus sine x squared. And on the right side, so everything's already in sine and cosine. So then my next question would be, what can I do to simplify? I'm just going to fix the screen for a minute. So on the left side, what can I do to simplify? Well, I can expand my brackets, right? That's pretty easy to do. So I'm going to write it out twice so you don't forget all the terms. So we've got cosine times cosine, and then we have minus cos x sine x twice. And then we have sine times sine. And so the middle two terms are like terms, so we can add those two together. I'll just put the sine x first. It doesn't really matter whether I put the sine x first or the cos x. And since the other side is sine x cos x, I'll do the same. So always keep in mind what you have on both sides. So I've simplified by expanding, collecting like terms, and then I kind of compare it to the other side. And I can see that the 2 sine x cos x is the same, but the cos squared sine x is different. But I do know with my trig identities that sine squared plus cos squared equals 1. So I will replace that, and then the left side equals the right side. So that's pretty easy, just expand and simplify. All right, second one. Similar to the first one. What can we do to simplify? It's already in sine and cosine. So what can we do to simplify? Well, we can expand. I'm not going to do anything to the right now because it's already in cosine and there's not really much to do. So I'm going to expand the left and see what we get. So we get sine squared y minus sine y cos y plus sine y cos y, and then minus cos squared y. And then I collect like terms. Well, I see the middle two terms add to 0. So same strategy as before. Is it in sine and cosine? Yes. What can I do to simplify? I can expand and collect like terms. Now I'm going to compare. On the right side, we have only terms that contain cosine, right? We have 1 minus 2 cos squared. On the left side, we have sine and cosine. So what I want to do is replace this sine squared with something that has cosine in it. So here I'm replacing for a reason. The reason is I don't want sine, I want cosine. So once I've done that and collected like terms, I get the same as the right side. So that's my point about replacing or changing things. You must have a reason for it. You don't want to just randomly change things because, right? So there needs to be a reason so that you're not going around in circles. Okay, number 3. Left side is cosecant squared x, 1 minus cos squared x. right side is 1. So this one is pretty straightforward. Nothing to do on the right, just equals 1. So on the left, is it in sine and cosine? No. So I'm going to change this to 1 over sine squared. Then I kind of look at the right and I say, well, it's 1. If I want it to be 1, then I would need to change 1 minus cos squared to sine squared x, and then that reduces to 1. Okay, that one's pretty easy. So I change cosecant to sine. That's my strategy. And then I look at the right side. Well, I need a 1. So that means the numerator also has to be sine squared x, which I know is the same thing as 1 minus cos squared x. Easy peasy. Okay, number 4. Left sides. This one. So it doesn't really matter whether you do a t-chart or you do left side, right side. I kind of prefer a t-chart because I think it's neater. So on the left we have cotangent squared minus cosine squared. And on the right we have cosine squared x times cotangent. So first strategy is change to sine and cosine any terms that are not in sine or cosine. So on the right I'll change cotangent. To cos squared over sine squared. And then what can I do to simplify? Well, I could just multiply. So cos squared times cos squared is cosine to the power of 4. And then that's all I can do. So I changed the cotangent. I simplified by multiplying those two terms together. So let's go to the left. What can we do? Well, we can change this to cosine over sine. What can we do to simplify? Well, we could find a common denominator and subtract these two terms together. So the common denominator is sine squared. Put them together. And then I compare. Okay, so when I look at the right side, I see that the denominator is the same. Both of them have a denominator of sine squared. When I look at the numerator, the right side only has cosine in the numerator, the left side has a sine there. So I don't want that sine. So there's one of two ways to do this. I'm going to show you both ways. One is to just replace it. Right? Just replace this if you want to do it that way. So we're going to replace sine squared with 1 minus cos squared. And that gives us cos squared x minus cos squared x plus cosine to the 4th. So all I'm doing is expanding, right? Cosine squared times 1 and cosine times cosine. And then the cosine squares add to 0. And that leaves me with cosine to the 4th over sine squared. Or you can factor. Some people like to factor. Some people see this and some people don't, so it doesn't really matter. If you don't see it, you can do it the original way, but this is what we had up here. We had cos squared x minus cos squared sine squared. If you want, you can factor out a common cosine squared. Both terms contain a cosine squared. So cos squared goes into cos squared once. And then you can then replace 1 minus sine squared with cos squared. And then multiply the numerator and get your cosine to the 4th. Okay, so it doesn't really matter which way you do it. There's two options. You could just replace the sine squared with 1 minus cos squared, expand and collect like terms, or you can factor out cosine squared and then replace 1 minus sine squared with cos squared. So both ways are fine. Okay, number 5. Okay, number 5. Okay, so on the right, nothing to do. It's just sine squared. We don't need to do anything with that. On the left, we have tan squared x over 1 plus tan squared. So I'm going to change terms to sine and cosine, since they're not in sine and cosine, they're in tan. So tan squared is sine squared over cos squared. And do the same in the bottom. I like to keep the numerator and denominator in brackets so I don't get them mixed up. Okay. Then on the bottom, I need to find a common denominator to add those two terms together. So I'm going to change the 1 to cos squared and do the same to the top. So on the denominator, I will have cos squared plus sine squared all over cosine squared. And then to simplify, we will take the numerator and then multiply by the reciprocal of the denominator. And we always want to reduce at this point, not expand, right? We always want to simplify by reducing. And when I look at the other side, I have sine squared, which I have in the numerator. And then I would need to change this cos squared plus sine squared to 1. So sine squared divided by 1 is just sine squared. Okay? So change to sine and cosine. We need to simplify the denominator by adding those two terms, finding a common denominator, and then simplify by taking the numerator and multiplying by the reciprocal of the denominator, and then reduce if possible. Okay, that was number 5. So number 6. So I may be going quickly, but you can always go back and look at these when you're working on them, right? So it's always nice to have the answer that you can check if you get stuck. Right? So if some of them you don't get right now, that's fine. You can always go back and look at them. Okay, so on the right, we have secant. So I'm going to change that to 1 over cosine. And then what can I do to simplify? Well, I can just multiply them together. Okay, easy peasy. So that's fine. On the left, what can I do? Well, I can change any terms. Secant is 1 over cosine. So I'm going to multiply that by sine squared. So that's in the numerator. And then in the denominator, we have cos squared, and then we're going to change cosecant to 1 over sine squared. Right, so this is 1 over cos squared, and this is 1 over sine squared. So I'm just taking those terms and multiplying them by the other term in that numerator and denominator. So then I have to find a common denominator in the numerator and a common denominator in the denominator. So in the numerator, my common denominator is cos squared, so we'll do the same top and bottom, and in the denominator it's sine squared, so we'll do the same to the top and bottom. So that leaves me cos squared plus sine squared all over cos squared in the numerator. And then in the denominator, we have sine squared plus cos squared all over sine squared. And then we're going to multiply the numerator by the reciprocal of the denominator at the same time. The numerator has cos squared plus sine squared in the numerator. I'm going to change that to 1. And then in the denominator, the same thing. right? So I'm changing this to 1, and I'm changing this to 1 at the same time. And then I just multiply them together, and I've got the same as the right side. Okay, so a lot of it's finding common denominators. That's actually a pretty common theme. You'll see that in probably half the identities is where you have to find a common denominator. Okay, number 7. Isn't this fun? Okay, we have 1 minus cos y and 1 plus secant y on the left. And on the right, we have sine y times tan y. So on the right, I'll just change sine or tan to sine over cosine, and then I'll just multiply them together. All right, so it's not much to do there. Change tan and then simplify by multiplying together. On the left side, I'm going to change, I mean, you can expand and then change, or you can change and then expand. It's up to you. I'm just going to multiply out the brackets, and then I'm going to change the secant. So I've got 1 times 1, 1 times secant, minus cosine times 1, and minus cos y secant y. So it doesn't really matter whether you change at the beginning or in the second step. Okay, so what can we change? Secant is 1 over cosine. Then we have minus cosine. And then we have secant is 1 over cosine. So cosine divided by cosine will simplify to 1. And then this 1 subtracts with this 1. So now we have 1 over cos y minus cos y. So we'll need a common denominator to add those together. So we will get 1 minus cos squared y over cosine y. And when I look at the right side, I see that the numerator is sine squared. The denominator is the same, but I do know that 1 minus cos squared y is the same or equal to sine squared y. So I will just replace that. Okay, and then the last one, 8. On the right side, we have sine squared x minus sine squared y. And then on the left side, we have sine x cos squared y minus cos squared x sine squared y. So it's already in sine and cosine. When I look on the right, there is only sine. And when I look on the left, we have these cosines. So I'm going to replace those. Right, because I don't want cosine. So I'm going to replace cos squared with 1 minus sine squared y. And I'm going to replace cos squared x with 1 minus sine squared x. And then we will expand brackets. So we have sine squared y times 1 minus sine squared x sine squared y. And then we have minus 1 times sine squared y. And then a negative and a negative is a positive, sine squared x sine squared y. And then these two terms add to 0. And we're left with sine squared x minus sine squared y. Okay, so all we had to do was replace, and the reason we replaced is because the right side only had sine, and the left side had sine and cosine. So the purpose of replacing the cosine was that we were only using sine. And then once you expand and collect like terms, you'll find that the answer falls into place. Identity.